Hello, everybody. Today is November 2nd, and it's an asynchronous lesson on matched pair design. So what is matched pair? A matched pair is really just a special case of blocking, and all blocks are size 2. This method can be used when I have a method to pair subjects or units that are very alike. So if there's some natural pairing that happens, then I can use matched pair. And there's also the case where subject units can receive both treatments. So that's another case of matched pair. When possible, this design is preferable as it eliminates variation that happens from subject to subject and unit to unit. So let's look at an example. A company has just formulated a new mosquito repellent to replace their old formula, and they would like to test if the new formula is more effective. They have a tank of mosquitoes and 20 volunteers. First, before we get into the matched pair, let's describe a completely randomized design so that we can kind of compare the difference. So for a completely randomized design, step 1, my random assignment. I'll number all my 20 volunteers and put the numbers in a hat and choose 10 for group 1, and the remaining go to group 2. Step 2, assignment the treatments. Group 1 will get the new formula on their arm and put it in the mosquito tank. Group 2 will get the old formula on their arm and put it in the mosquito tank. Step 3 is our comparison, and then they'll measure the numbers of mosquito bites on the volunteer's arm and compare the mean bites of the two groups and see if the new treatment had less bites than the old. All right, and the question now becomes, can we do it better? Completely randomized designs are fine, and they avoid confounding. But there might be a better way that will reduce the variation that can come from other variables. So if I think about this design, they each put mosquito repellent on an arm, and the volunteers all have 2 arms, so each one can have both treatments. And this, in effect, is a block of size 2. One important thing to know is during this sort of design, we still need to use random assignment. So we have to have that component of the design, and let's talk about how we can do that random assignment. Okay, for matched pair, we randomly assign treatments to the pair or the order of the treatments. So let's see in this example what it looks like. Random assignment, I'll do that first step is the same. Number all the volunteers, put them in a hat, choose 10, remaining go to the other. Assigning the treatments, here's where I have a difference. Group 1 will get the new formula on their right arm and the old on their left. Group 2 will get the new formula on their left arm and the old on their right. So notice both groups get both treatments, but they are randomly assigning which arm the treatment goes on. And I randomly assign because there are things that I might not think of. Maybe there are more right-handed people and they're more likely to swat away the mosquitoes with their right than with their left, or some other factor that I haven't thought about. Random assignment takes care of things that variables that I haven't thought about. So I still need to use random assignment. After that, I compare and I find the difference in mosquito bites for each participant, the old minus the new. When we do compare and matched pair, part of that variation reduction happens sort of like that I'm subtracting in there. The other one, I'm comparing 2 different means. Here, I really just have kind of one group. So that's where that reduction comes from. So that's kind of it on the example for matched pair. There's a few more elements of design that we will continue talking about on Wednesday. You all have a great day, and I will see you Wednesday.